Okay, let's actually get started then. Oh, we're talking about freaking flea markets and cars and whatever. We don't talk about cars on Saturn Stream anymore. At least not when we're doing stuff. What's going on? We're on my monthly format now, so I'm only going to do like 1 or 2 streams a month. One of them is going to be a Sadiator test stream, and today we're doing the belated 3D birthday blast. I was supposed to do it last month, but things came up and I got lazy, etc., etc. Here we are now, and what's going on is that with the imminent retirement of XL2 after he's done with Project Z Dream, we are still searching for a good answer for a reliable 3D pipeline that will be maintained. So Ponut has essentially picked up the torch and gotten started since his Pony game has been a lot of his own work, built on top of, I guess you could call it almost a fork of the Z-Dream engine, based off the public release of the Sonic Z-Dream stuff and the Z-Dream format that XL2 has done. Ground loop. Okay, let's solve this. First, let me turn off that. Is there an audio issue with the music off? I can't tell if I got like a bad filter or noise gate suppression, something like that. Maybe I need to. It doesn't persist. Yeah, that would help. But yeah, anyway, let me get the music back on to try and hide problem, and then I'll see if Shane ever comes back on. I'm sure he can help me bug check it or whatever. Actually, I'll probably tell Shane I'm going on. But yeah, so Ponut has been working on his pony game, and as part of the process, I think I might have talked him into, if he didn't talk himself into, creating his own format for 3D development. So, let me see if I can bump on over. Oh, I should probably switch views to on-screen. There we go. No, let's start out with the Saturn stuff, and then we'll ease our way into everything else. So, Ponut has his own custom format now, which is essentially a fork of the Z-Dream format, but I'm going to see if I can't help out and get this thing up and running. I think the goal for tonight is to be nice to myself, understand what's going on, understand how the 3D stuff works, and see if we can help a little bit with documentation. If I get really confident, what we can do is we can try and make headway into Blender and see if we can't get Blender to automatically export the Ponut's format, which I believe we're going with the Great Value format. Yeah, so I think as far as the Sega Extreme folks go, I think I'm better at documentation than writing brand new tooling. I'm always relying on other people for helping hold my hand through a lot of the specifics in terms of the hardware. I can do logical loops and structures very well. I just can't get my head around a lot of the Saturn hardware. I usually have someone babysitting me while I'm doing that. So my contribution to the Great Value, what's GVP? So Great Value Pony, Great Value Ponut, Great Value file spelled PH. Great Value Polygon, there we go. So, my contribution for the Great Value Polygon will be an attempt at an automatic exporter from Blender. We'll see if we can't adjust Romulo's UV mapping approach to work for us. I mean, that's a little bit ambitious, but we'll see how far we get. But at the very minimum, I can try to help document it, or at least someone can watch my stream and say, okay, that's what he's doing there. So we already have, this is going to look disgusting because there's just so many files, but really all we need to pay attention to is, this is basically Ponut's entire library. I think his game is hidden in here somewhere, except I've overwritten the main file. We have I believe we're showing B Pony right now. Let me check. What are you loading up as your... Okay, yeah, we're loading up B Pony. Yeah. So I downloaded the entire GitHub from Ponut's GitHub or his stuff GitHub project, which is what he's labeled his pony game. But right now we're only demonstrating pony. I guess we could probably try to demonstrate something else. Is this a tree missing the E? Yeah, you told me to download everything. Yes, it's tray. Okay, so let's try loading up tray. Wait, so we're loading up box and bpony. Can I swap between these two in the file? Or let me, whoops. Okay, let's, whoa. Okay, that was quick. I accidentally precompiled this thing. Test entity. Okay, so here is the basic render demo. So we're going to try and get some bare bone stuff here, comment a little bit, figure out what's going on, and then maybe I'll try to get one of my own figures in here using the exporter that's available already. And then if we have time, we'll see if I can't make headway into making the exporter using Blender. I believe Blender plugins require Python. Why would you remove comments? I don't understand why, like, if he had thank you for Fatman Jacking. Do I really have to say Fatman Jacking? Well, thank you for the follow, Fatman Jacking. Assuming that is your preferred name, if you don't have a better name to go by. Okay, in and out, in and out. Can I switch models? It appears not. Okay, maybe I can get the triggers to switch models. This is a bit aggressive for a background track. I think I'm going to take this off the list. Your T-Lopes is going to be mad at me if he ever finds out I do this thing. Close enough. Okay, we can go in and out. We can get a little closer. I think there's a little bit of sorting issues going on over here where, like, the hair, the mane, kind of gets clipped by the eye, and I don't know how you're sorting these guys. This is not using SGL, correct? This is just your own custom Z-sort code, or sort_sent. So you're taking the centroid of the polygon. Okay, so we're right now we're out. We are no longer using SGL. This is just that. Oh, I see why. Because the center of these quads are big enough so that the center is behind where the eye would be. All right, I get it. Wonder if there's a way to fix that. There's not really a foolproof Z-sort that isn't expensive, is there? Alright, let's try doing a modification like that. So. I don't understand this indentation here. So we'll just do... So, we'll do 3D entities to display. Fine. Display. What are these points for? What do these points do? This looks like you just put like a 5 by 10 by 10 square somewhere. So this is like a custom box entity. Okay, so I'll just leave that there. I'm not sure what comment to put there to that a useful comment. I'll just do directional test objects. Sure. Point in a polygon. What's going on with this indentation? I'm guessing all this is that. Do we actually use any of this in the demo? Look like they're implemented. Initialize. Okay. Okay, so this is just initializing some point. I'm guessing is just going to start out where we are. Alright, we'll get to that when we get to that. So this is our synchronization constant. Frame rate. Guys, I believe they perform a similar function. We usually just set one to the other. And then we're going to do our loading pointers. So it's the same loading setup that I copied for Forsaken Plane, where you use the beginning of low work RAM up to a certain point to just load whatever you want and then move it to where you're going to put it later. Why is this definition so low down there? I'm going to put that up here. I tend to put all my definitions up near the top. This is graph X offset. Why does that need to be defined? Okay, whatever. Also, this. What is this Okay, this is the comment for this. So, this function... This song. Go ahead and pass on this one. Yeah, close enough. There we go. So, DT shifted right by 6. I'm not sure if I get what's going on with this. So the frame rate, I'm guessing... What's DT going to be? DT is going to be measured in seconds. So that means, let's say we have 16 milliseconds. That's going to be basically already like having 16 shifted right a few times. Or not 16, I'm sure it's represented somewhere else. Is this like a quick and dirty way of doing a, figuring out how many milliseconds you have per frame? Let's go over to Wolfram real quick and just have it do math for us. $16 by 5, or sorry, by 6. No, I bet I probably could just do this using the calculator. I think the calculator does this already. I'm just so used to using Wolfram for the algebra stuff. Okay, so let's go over to the programmer's calculator. Take 16 and then right shift by 5. 0. Okay, no, it's not 16. It's 16 left shifted by 16. Okay, and then no, what's 16 divided by 1,000 as represented by okay, going back to Wolfram. So we have 0.016 times 2 to the 16 divided by... Oh, no, just 2 to the 16. There we go. So we're going to have basically 1049 probably. And then we shift right 6 times. What do we get? 16. That doesn't make any sense. Okay, so let's take 16 milliseconds because the timer is running seconds. If we're using the same timer that we built for a scenario way back when, 16 shifted left that many times, and then shifted right 6 times. It still comes out to 16. How's that work out? So if are you just returning milliseconds? So your frame... This says frame rate. This is more like a frame time. Okay, so this is approximate of frame time in milliseconds. It's weird how that worked out. It's not going to be exact all the time. It's definitely going to have rounding errors, but it's going to be close enough. And because the Saturn is going off of divisions at 2 anyway, you already know what you're gonna get. If you got 16 or 17 or whatever, you know that you have that. What's 1 over 16? We get another calculator open so I can do normal math and programmer math at the same time. So 1 over 60 is 16.7 frames per second. 16.7 milliseconds per frame, sorry. Right. Okay. Now, what the crap is the 66th element of last times? Why do you have 66 elements? This is going to be previous frame time, and then we're going to update the frame. Oh, okay. So this is the frame graph tracker. So it's 66 pixels wide. Is that graph that you have up there? Now the time selector is set to 0, and that's your frame rate. Okay. But then you make it. Okay, so does the static mean that this becomes this is persistent, so that the next time you run this function, you can iterate it and then have it function the correct way? Then you count your bad. How do you even calculate your bad frames? Let me see. We're gonna track frame times. Okay, so if you have a bad frame is one in which you've exceeded 40. What does 40 mean? What's 1 divided by 20? That's... Okay, so if you dip down to 20 frames per second, that's a bad frame to you. FPS dips below 20. Well, it's not 20. It's what is 40 frames? 40 milliseconds a frame. Oh, for we invert that. 25. Now the Saturn's not going to reach 25. It's going to go from 30 to 20. But I guess that's your boundary. And then your time selector, if it's greater than 66, then how the heck does that work? If it's greater than 66, you add one to it? Oh no, you set it to 0. Oh, okay. Right. I read that backwards for some reason. So selector, iterate. That makes sense. So, like I said, these guys are persistent. So every time you call the function, whatever is there is already there. So you don't reinitialize it. That's what the static does. Why can't I type? Persistent variables. Normally, when I use these kind of persistent variables, I define them up top. But I like this way better because then you kind of compartmentalize what's happening. Easier to read. Okay, so then we shift 4 again. So if you already have why do I keep going back to that when I got the programmer calculator? Alright, there we go. So if you already have you already have 16. You shift right 4. Is that just going to get you 1? Okay. So that gets you that frame rate constant. So if you, for some reason, had, what's 16.7 times 2? Oh, crap, I can't do that. 16.7 times 2. So if you had 30, let's call it 33, and you shift right 4 times, it's going to get you your 2. No? Yes, there we go. So then one is one's gonna be 60. So get equivalent of sync constant. One is 60 FPS. 2 is 30. 3 would be 20, etc. Yeah, okay. Then you're going to print the bad frames on there. That's self-explanatory. Oh, single line if statements. I hate these. Frame rate is less than or equal to 0. Frame rate is equal to 1. How does that... How would it get that way? How could you get a negative frame? Okay, well that's... fix erroneous shift. So if somehow the frame rate was measured at less than 16 milliseconds, which shouldn't ever happen, but even if it did, we just bump it back up to 1. And this one enforces... What's 5? Is that 1 over 20? So okay. So it's 60 divided by 1 is 60, 2 is 30, 3 is 20, 4 is 15, 60 divided by 5 is going to be what, 6? Well, sorry, I can't do math. 12. So that means enforces 12 FPS floor. I mean, I don't know, it makes sense to me. Like, if the human eye, as the memes will tell you, can't see more than 30 FPS, but it definitely can't see less than 12. You start doing less than 12, things look like slideshows. I hope they just don't quote me on the 30 FPS part. That's what people who only play consoles use to excuse their poor hardware choices. All right, current line is frame rate. So the frame time. Current line is frame time. All right, so that's just where you draw the line. Previous line is... All right, yeah. Okay, so we're just getting the previous value of the last times. And then the nth line... I'm not sure what the nth line is meant to do. So there's a current line, that's just the frame time. You're just plotting how long a frame takes. Previous line is the one before that. Nth line is the one before the previous one? I guess? Okay, whatever. Yep. And then we're just drawing the line. Wait, we just went through this. This is just, Okay, let me go ahead and label this guy. Update game speed. This runs the timer and displays a frame graph. Okay, that's what that does. Now we can close out of this. We know what that does. That's just the frame graph. So that's the that error thing up there. That go. We already know what this is based off of my run through from Forsaken Plane. So initialize low work RAM. RAM addresses. There's your dirty buffer. I don't know how big this is. Some number of megabytes big, I guess, however big you need for whatever. Okay. I'm not sure what this number is meant to do. Okay, yeah, but why are you adding 1 megabyte to the low work RAM address? What, does that get you to high work RAM? Oh. Okay. Let me go ahead and write that. Buffer is the last. Damn, coughing over here. Okay, is the last 64 kilobytes of the 1 megabyte low arc RAM. I'm not sure what this thing does. I'm going to keep this comment in because it seems important, but I have no idea how you discover that or how it's going to affect things. But apparently, there's a dark spot in low arc RAM. Is this emulated or is this hardware? Oh, so this is real. So the Saturn has a RAM defect. Interesting. I'm not really sure what PCO texture definitions is doing in here, or what this comment is doing. So is this is the designated so this is going to be designated color palette area. Can I not spell palette correctly? I believe it's 2 T's and 1. Wow, that's the worst way to spell it. There we go. Okay, but that's good to have in mind, though. So the largest entity that you could theoretically have is going to be 256 kilobytes, and you need to put it at the very beginning of one of those sectors. So maybe the RAM is physically 4 clusters of 256 kilobytes that just can't be addressed simultaneously somehow. Okay. So I'm assuming PCO. I recognize that. That just for me that's when I use the color palettes. You're using a color RAM mode that I'm not familiar with, that I saw earlier on, but or maybe I was wrong. Texture definition textures. Whoops. So you have a designated location to store textures. Why aren't they stored in video RAM? Oh, okay. So this is designated texture, I guess pointer location, pointer table or whatever, so we can just quickly load up and swap between designated textures. Pointer storage, I guess. Yeah. Okay. Okay, let me get that open and then I'll. Whoops. Where's render? There we go. Render.h, render.c, and we have. Whoops. Let me get that back open. PCO text defs, I believe, I guess, would be somewhere up here anyway. CO. It's not. What? Oh, there it is, right there. Under palette codes. Palette code has a size and a source. Oh, okay, so this is what a custom struct that you have that will list all the things about the texture that you need. Okay, helpful. That's commented out. Well, this is straightforward, right? We've done this as far as like the first stream I ever did was something like this. Initialize camera. I see you're still using Joe Engine. Interesting, considering that you've moved away from SGL on the 3D rendering side. I'm guessing you're gonna end up eventually like XL2, where you just completely throw away any semblance of needing Joe Engine or SGL and just try to do everything custom. Okay. So, SGL Z display level, okay. Perspective. We're just getting the camera set up here. Oh, well, here's the thing. Joe is on Sega Extreme, and if you add him, he will eventually respond. I've gotten him to respond to me once or twice, I think. Let me see if I can. When's the last time I talked to him? It's good. It was a while ago. Yeah, all the way back in February, like a year ago, almost exactly a year ago, I managed to talk to him. But I was just talking about adding my project to a list of projects. Here's the thing, though. One man can't do everything. Well, except XL2, but he's not sharing a lot of code, at least not the updates. Joe created a fantastic entry point. What Joe did that I am so grateful for is that he has a folder full of samples that, for the most part, seem to work. And they're commented. So he has... What everyone likes to do, for some reason, is to create these good tools with hardly any documentation and no real tutorials, and then throw them out there, and then people bang their head. Like, for beginners that are new to not only coding, they want to start a new project. They're learning the coding at the same time they're trying to learn hardware, and then they also have to learn how to do things like they're making art. They're having to find royalty-free sound effects, or God forbid, trying to create their own. Yes, it's a fantastic learning environment. Not everything works. We've had to fix a few things. I made my own custom timer just because I couldn't rely on the Joe Engine timer for some reason. And after a certain point, the sound stuff didn't work for me, so I ended up having Ponut help me make a new sound thing. But for what it does, which is get your foot in the door for 2D games, is fantastic. Forsaken Plain is 100% a Joe Engine game, and it just works. Well, it's not 100% a Joe Engine game. It doesn't use the custom 2D tools. But it relies on Joe Engine as a base, and I would not have been able to make it without looking at how it was handling other things, because the first versions of Forsaken Plain were completely in Joe Engine. I did move on to SGL, and eventually I'll probably end up moving on beyond that, if I have to. Okay, set camera. I'll just put the name up here, but this is relatively trivial. Set camera. So this one, view along positive, or just let me call it Z positive. But I don't get, why is Y negative the designated up direction when you could have made everything on the XY plane and then have Z positive, the upward direction, and just go look toward Y negative. That would make more sense to me, because that's how a lot of the 3D modeling software that I work with works. Like when I do 3D simulations in COMSOL multiphysics, default view is more or less Z up, and that's just what you're used to. Or if you're doing math on a chalkboard or whatever, if you still have chalkboards, tend to put either Y is up on 2D, Z is up on 3D. Hey, VBT's in! What's up? Thanks for noticing us, Senpai. Wait, what's the rest of this stuff doing? What is all this? This is just in the middle of nowhere. What's going on here? Oh, well, thanks for joining us. I appreciate you coming in and watch me comment someone else's code to try and figure out what's going on before I attempt to be helpful and just end up making a fool of myself on camera. Well, not on camera, but you know what I mean. Okay, Ponut, what are these guys? They're in the middle of nowhere, but they're doing something. So this is camera target angle. I can get that much. Polygon count? I got into a small minor argument with someone on Reddit, which is always a bad idea, about what constitutes a polygon, which apparently, according to enough people on Reddit, where it's a weird popular opinion that only triangles are polygons. It's a weird argument to have. I didn't think I'd ever have to have it. I didn't think that it would ever be an argument to have. But, you know, I have a piece of paper that says I know math. Okay, can I just delete this? I'll comment it out, just to be safe. What's light do? You maximize light along Y positive, which is the downward direction? Or is that's not the source of the light, that's the direction of the light. Light source vector. So you're lighting your... Can you have multiple light sources, or is it once at a time? Okay, I know it's directional light, but can you have 3 directions of light, which is... okay. I imagine that would slow things down tremendously if you're calculating light by your own custom whatever script thing. Really? Are you doing it via DSP? Oh, there we go. Raw. What does this draw? Draws test entity. Okay. Because ideally, whenever you're displaying like a test thing in 3D, you want like 2 or 3 point lighting. Well, not point. It doesn't have to be a point. It can be 3 plane waves hitting it. But if you have 3 plane waves of different intensities, it kind of helps display the thing in a way that gives you enough depth perception to know what's going on. Which is, I think, the default when you use Blender. We need... I'll leave it in. I mean, this is all stuff that we've seen before. It'll take me a little bit to try and refigure out what's going on here, but we have a push matrix, and then we have translates, puts the thing at where you want to put it, which in this case is 1 Z, well, whatever target is Z away. I'm assuming this is an integer, or no. Shifted left by 16. So this is an integer, and it's going to get shifted left to turn into a float. And then the rotation, I would think that rotation would have to be an angle, would it not? But you just take an integer angle, and it just knows what to do with it. Yeah, okay, I remember it was up there. Somewhere. Put it. Put it somewhere. Oh, there it is. So 0, 0, and 30, so it's 30 away. And X and Y are the rotation... Okay, so you have rotation vectors, and then... Oh, this is a dirty way of doing this, isn't it? You have your Z component as an integer location, and then your X and Y component as integer angles? Okay, yeah, I would have done it different, but whatever. And then no rotation along Z, because why? Wait. Oh yeah, you can rotate it around. Okay, yeah. You're just going in and out, so this is just a display. I get it. And then SSH2 draw model. Wait, why is SSH2 drawing things? Shouldn't it be VDP 1 or 2? Probably 1. Or am I understanding that wrong? Why you gotta give me that bra? I'm learning here. Okay. I'm learning things. Now, for those of us who don't know what TNL is, could you describe it, please? Okay, right. Got all that industry lingo. Working on the Sonic movie or whatever that's coming out soon. Where everyone got fired. I'm not sure what this matrix does. MS sounds like a bad thing, but who knows? Running frame. What does this guy do? This is our main loop, isn't it? Master matrix. Do we use this for display? Is that what's happening? Oh. Huh. Okay. Using this trackball mouse, but I think it's a little dirty or something, so it's kind of hard to get exact. I just had to quickly clean my mouse out. There we go. So we have great value render. Okay. So we have vertices, polygons, and then polygons sent to SSH2 and MSH2. So then you'd want to have a, I mean, obviously you want to discriminate between the level and actual movable characters, but yeah, that, sense. I think ideally you want to have lighting active even on the environment, so you want everything to be lit in an active manner. So like, let's say you had a character, you can use like a light or a torch or something like that. Things look different with the torch on than off. But yeah, they can both light. So what is the key differentiation between the MSH and the SSH? Got to handle input area here. So then, why are you differentiating between? Does one have more capability than the other, or is it just slave and master? So the master is also where we put all of our normal logic, right? So do we want to have the slave to give more intensive jobs to, so it can focus on it? Right. So what I'm saying is, the master is already handling a lot of logic stuff. I assume, if we're going to be splitting the jobs between the two processors. Yeah, so if we're going to be splitting the job between two processors, the master is already busy running everything. We might as well give the slave the harder job if we're going to split the jobs in half. Is that the strategy we're talking about here? Between, sending level data over to the master and then having the slave handle the animated characters? Oh, okay. But you have the master in here as a I guess as a backup. Do you actually activate the slave in this demo? I'd like to see the code that does that. My v blank. This is what an SGL v blank wrapper looks like. What's going on here? Why is there a separate operate digital pad? Oh, is that your input handler? Is in running frame. Oh, did I miss that? Send drawing function to slave. So then the drawing function, was that in main? Yes, it was. How do you synchronize? Is there a wait for v blank in here? Because it looks like this thing just loops. Or would loop. Or does it run it once per v blank? Is that how this works? Ah. Wait, where? It's not in draw, so how does the slave know to wait for SL sync? It's here. So SL sync synchronizes both the master and the slave. I thought you had to send it to each. I guess I was using it kind of like v blank. But SL sync makes sure that whatever the main loop is running for master and slave, both of them are repeating at the same time. Okay. So what I'm thinking, or what I'm worried... Okay, so the slave is not looping. The slave is being sent a draw command by the master pretty early on, I think. Well, not that early on. But early enough on. So the slave is being sent a draw command. The slave will complete the draw command, and the master will wait for the slave, assuming the slave is slower. The slave finishes early, that's not a problem, because the master's still thinking. So, okay, so there's no potential conflict. I'm thinking of a potential conflict like screen tearing, where slave somehow will try to draw 1.5 times or something. Apparently that's not a problem. Okay. Glad that works out. Probably thought a little bit too hard on that one. So this is... We're treating Joe main as a initialize game variables and start main loop. We have initialize engine. Okay. What's dynamic frame? Oh, okay, dynamic frame rate. Right. You just... is color RAM mode to 24 bits per pixel. And then sync constant is what it always is. It's our frame rate controller as an 8-bit integer. Signed. Why does it need to be signed? Whatever. Okay. Initialize RAM. We have initialize will work RAM and initialize render area, which I believe would be somewhere in here, right? Yeah, there it is. I don't want to just keep getting recursively deeper into this, but we are at the end of the file, so might as well. Initialize render area. Okay, let's read this out loud just to see. Hello, XL2. I bet you're wondering why the hell are we uncaching this? The theory is that these work areas are invariably going to be rewritten every time a model is rendered. This means that the data cached in these is only useful within rendering a single model, not for multiple. If you're rendering multiple small models, you'd rather fill the cache with point tables and point table data. Huh. I don't understand what's going on there. I mean, if SGL says it's signed, but I mean, I don't know what a negative frame constant would mean. I feel like you need much more powerful hardware than the Saturn is doing in order to go backward in time. So, I'm not certain what you're trying to communicate to XL2 here. You're saying that you're changing how caching is working by... Instead of... What is XL2 doing? Maybe it's because I don't understand what XL2 is doing. So your argument is that he has a cache that he's constantly rewriting anyway, so it's not helpful to continue to keep rewriting the model state to memory every time you use it. So you are filling it with, I guess, a point table that you can look up and then just load from standard RAM or wherever the RAM is. Okay, how about we don't worry about it? I agree with Ponut because it's a little bit over my head and it's not what I'm trying to get wrapped up in right now. Point is, we can load these guys, Box and bpony. Where are these being stored, though? Well, while we're doing this, sort min, opposed to sort center. We have this one song, Sonic and the Secret Rings, but it's a little bit weird. I'm gonna drop it from the lineup. It's not that much better. I guess he always ruins things. This is also a little bit too weird for me to put in the background. There we go. Okay, so Ponut, let's say, hypothetically, I want to be able to switch between Box and bpony. How do I know where these guys are stored so that I can switch between the two? Okay. But let's say I want to put these into a list. We have other entity and test entity. Yeah, I was going to do something like that, but I was going to iterate it. So let's try an array. I'm going to probably end up breaking this trying to do this modification. Int list. And let's be able to put in, let's do an arbitrary number. Okay, let's do slightly less arbitrary. Okay. And I'm going to do loaded ints 0. And then int display is also going to be 0. Okay. So let us where do we load stuff up? That's going to be down Joe main. Right? Yeah, there we go. Int list 0 or int list this ID Okay, let's do it this way. And I'm hoping that this doesn't break things. So the idea is that we're pointing to the next entry of, well, we start at 0 and then we iterate, and then it's become 1, and then here it'll be 1, and then it's going to iterate. And at the end, I just have to remember to do loaded ints minus minus, and then everything's all good, and now you just keep copy pasting code without worrying. Also, maybe let's do sort min. Just to play with it. And now we can start loading up everything. So what is in our, not that, there. What is in our CD? Got box pony bring juice. I can't understand the freaking name. Oh no, you're breaking my testicles here. Okay, so basically what we have is 1, 2, 3, 4, 5, 6, 7 GVP files. And we're loading up 3 so far. 4, 5, 6, 7. Got box, pony, ring. Juice. Pillar. Shadow. And tray. And now we have to go over to... I'm not sure what these are supposed to do. I'm not going to play with them. But where do we do the thing where we draw it? There, draw. Comment that out. Place with. Where was I? There it is. Okay. Disp ID. There we go. Display ID. And then we have to iterate display ID using some sort of controller thing. Like this. So the key is now right trigger, left trigger, right? Okay. Is this something you made or is this something I made? This definitely doesn't look like something I made. DGR. Okay. I assume by is J, it's you mean is key. Is key change. Do we want change or do we want down? I think down is more appropriate. Because otherwise you're always going to go by 2 at a time, right? Or by change do you also mean down? I think is key down would be the appropriate. Why do I want change? If I change, that means if I hold down right trigger, that's one change. If I pull it back up, that's another change, is it not? That means I have to change by 2 at a time every time I press the trigger. And I want to be able to change by 1. Where's this bug going? Okay, so does change actually mean key down last frame? Struck. Okay. I just have to... I'm just going to do disp ID plus plus. And then disp ID. Wait a minute. Is it lowercase d or uppercase d? Lowercase, okay. Minus minus, and then we're gonna sanitize display ID. Dang it. So disp ID is equal to min max disp ID. So the max it can be. Okay, it's well, the max is going to sort out what the minimum is, and the min is going to sort out what the maximum is, because that makes sense. So max is going to make sure it's at least 0, and min is going to make sure it's not above. Then loaded entities. There we go. The directives to DG. Oh, that's right. Okay. Let's see if this doesn't completely break the code. Oh, boy. How did that happen? Wait, no. Oh, you know what I did? I probably overwrote the make file. Did I? No, I didn't. What, is the compiler wrong? All count undeclared, first use in this function. That's not good. How did that happen? I didn't change it. I just commented stuff. The only thing I changed was that one swapping to the array. Isn't that the opposite problem of what it's complaining? It's complaining that it's trying to use it and it's not declared. Oh, that's right. We commented it out. So let's comment this out. All right. Display underscore ID 237. How did I make that mistake? I didn't write it like that. Okay, that one was my fault. Let's do this. Any day now. What's different about it? I mean, aside from the speed, obviously, but... This is a box. That's nice. So, you guys, every time you guys mention changing GCC, the first thing I can think of is, why bother? It's already working as is. You're just asking for problems. So, what's the advantage to using GCC 9.2? Okay, let's see if changing keys actually fixes things. Interesting. Also, my triggers don't appear to be changing the box at all. Now, why could that be? First off, the display code. Let's see if the display code is actually doing the thing I'm telling it to do. It is trying to load up display ID. Display ID should be changing. What do you mean cached? Okay, please describe what you mean by that. Is there a different variable with display ID that I should know about? I don't think there is. Oh. So how do I force it to update what's on slave? Okay. So I just take this bit and put it over in draw. There we go. I can see how this is going to cause me big problems if I ever try to use a slave, though, because that means I have to have 2 copies of input handling, one for slave, one for master. Okay, so, well, I guess I'll talk to you about that another day. That's not the point of today, but the point is it's a solvable problem. We'll get to it another time. Okay, we got our box. Nice. Okay, move out, move in. I like I have one texture here. I'm not sure where that texture's coming from. Triggers are still not doing anything. Are you sure the Digi R and Digi L are what they are? Did you name them like right trigger, left trigger as opposed to digi-R, digi-L? L, R. Makes sense. Well, what changed? I mean, we can go back and use the Joe engine stuff. That works. Because Joe engine has an on key down, which should just work. Okay, so let's go over the Joe. Come on, Joe and did I have Bowie in here? Joe engine. Oh, I'll just go to go there manually. Oh, I had a link right there. I know they have an on key down, and I use that, or at least I used to use that. Then I made my own for some reason. So what we want is Joe key L, Joe key R, and we want to see it on input key down. There we go. I wonder if we're... nah, there should be a problem with slave accessing the stuff. Wait a minute. Yeah, right there. So, that, and then also... Come on. Give me the thing, jeez. The display ID iterate, display ID decrement, and then fix. That should work, right? So maximize between some presumably positive number and 0 will get you at least 0, but potentially more. Minimize between presumably some positive number at least 0, and loaded dense will drag it down to loaded dense. So if loaded dense should have been incremented every time we loaded a thing, so this should work. This should be an R. Then this should be L. Do that. Oh, freaking. Huh. You know what? I used the wrong version of that function, I believe. Joe is pad 1 key down. No, key pressed. Pressed or down? Down. I assume down is the just changed thing and not the currently being held down thing. The problem is we don't have consistent language anywhere for this, apparently. Try that. Oh, don't complain, freaking Sigwin. Or are you using min-GW now? I don't know. Okay, yeah, that worked. Now let's see if it actually works. Well, this version of it worked. What is this? Is that the ring? Oh, am I too far away to see the ring? Oh, there we go. That makes sense. I don't get this. How do you sort out whether or not to draw the top part? If anything, the closest part should be the one that's cut off first. Yeah. This frustrum calling. Are you doing frustrum calling or what have you? Maybe your frustrum's a little too skinny, or the I don't know. Angle's not quite right. But what kind of culling are you doing for display? I like how you see how many scent polys are changing over there. There's 48 polys somewhere in memory, but we only have to display a certain number of them. Go a little bit closer, we can get rid of all of them. Okay, anyway. There. What is this? I don't get what this is. Is this like a hot sauce bottle or glue? Is this glue? I'm trying to think of horse-themed stuff, and I don't know why hot sauce was the first thing to come up. Soy sauce or something. Oh, it's just juice. I can't read the texture on this thing. I assume it says juice. Is it upside down? Oh. And backwards. Interesting. Okay. Oh yeah, it's upside down and backwards. So if you flip this around, it should say juice. And this is a pillar, but... Oh, because I flipped everything upside down. I like the back face calling on the pillar. Something... Okay. What was between pillar and tree? There's something here that I can't see. Yeah, that's what I was saying. I don't know... If I knew what kind of culling you were doing, maybe I could figure out a way to just play around with some angles or something. See if I can get further away from this guy. There we go. I'm very far away from him. But this... Who comes between the pillar and the tree? Look real quick. Shadow. The shadow just doesn't want... It's telling us that the shadow is not rendering. See, there's no sent polygon for the shadow. Right. Is it because I didn't rotate? Oh, there we go. It was a rotation thing. Let me get closer. Okay, yeah, that makes sense. Okay, let me try to get closer on a real model, and then I'll go to the shadow. Here's the thing. I'm looking at the pillar from below when I should be looking from above, I think. Because presumably, you're only going to see the shadow from above it. Like, dead on like this. But no. I have to rotate until... So, the shadow, I think, is upside down somehow, or... I guess you just fix it by just rotating it 180, but, you know... Oh, now we're looking at... No, the tree is upside... No, wait. We have to see the shadow from underneath it, so yeah. Tree's right side up, shadow's upside down. What's next? Oh, you know what I should have done? Should have had them loop around to the beginning. Forgot to do that. There we go. There's our pony. Ponut's little pony. Oh, I changed the Z-sort. Let me see if the Z-sort change helped. Well, kinda. Min should be the closest one to you, right? Here specifically, Min is not working. Trying to figure out why that is. What is the minimum element here that is... Minimum should be closest to you, right? So... Oh, you know, maybe his nose is protruding further than the... Yeah. No, it's not. Isn't it? No, it's not. It's not protruding further than the face quad is not protruding further than the main, so that doesn't make sense. But what I'm trying to do is I'm just trying to get consistent behavior on this main. I want to know what it would take to do that. I feel like you could strategically create the model to avoid this, but you also shouldn't have to. Like the ear is clipping through the main now. Let's try one more time with sort max. see if we can get around this problem. And if that doesn't work, we'll just move on and then start looking at things like the lost my train of thought. Like the the model converter. Yeah, that's right. Why I downloaded code blocks. Okay, we got the pony. Let's get up nice and close. Dang, that's even worse. Oh, and I can see the whole quad there too. Yeah, that quad's about the size you need it to be. You know what you could do to fix this, if you didn't mind making the model more expensive, is break the eye in half. Have a top half and the bottom half in the eye. I don't know if that would fix that little corner piece there. Now I think about it, it might not. Right now we're doing sort max, so we're doing the furthest away from this. Probably worst thing we can do in this situation, I guess. Okay, anyway, let's set all these guys back to sort center. I would think that sort min would be not foolproof, but like a better general rule than sort center. Is it though? Because I'm always viewing it from behind. Oh, the sides is in, like, not from above. Okay, I get it. Misinterpreted that. Okay, so that's the model render demo, and that should be using the GVP format. What I want to know... Oh, let's go over to the load 3D model. We actually need to learn what this GVP format is doing. I want to try mapping it out. So let's go... Actually, let me get Excel. Excel? There we go. Dang it, go away. Those pop-ups. Okay, so where is load 3D models? That could be under render, or is that in some other thing? Let me see, we have animation definitions. That sounds like a good place to start. Render input in TGA. Oh, it's probably in TGA. Wait, why would it be in TGA? Shouldn't be in TGA. Animation definitions. Oh, that's a lot of stuff. Oh, this is just to animate the pony. It's unique to your thing. I mean, if you do an animated thing, you have to do something like that anyway, but it's not what I'm looking for. I'm looking for not input, rather the load 3D model code. But I don't know where that that code happens to be. mloader. But we don't include mloader. How are we getting it if we're not including it in main? I don't get it. Oh, no, it's included in render, isn't it? Yep, okay, my bad. I was looking in the wrong place. It's included in render, so it's only being called from render, so yeah, I was just looking wrong. mloader.c, that's what we actually want to look at. I'm not going to bother commenting everything, but I do want to look at the format for... geez. How did this stuff? Oh boy. Okay, we got file name. Okay, let's start doing a deep commenting on here. GV. What's GV? Great. Oh, great. Why am I? Great value. Load 3D model. Load in model from file name. into... I'm not sure. I'm assuming the start address is just wherever you're pointing that dirty cache or whatever you call it, that loading area that you have. I feel like you can get rid of this argument and just say, okay, we know where it's going. Just send it there. To loading area, start address. Model is converted to entity model. Displayed with sort type. Enumerated in hey, where is the display min, max, and center enumerated? Well, yeah, I mean, it's important, but when we call it, when we actually use this loader, where are we using this loader? All right. Oh, crap, I didn't mean to do that. There we go. I'm just trying to, okay, let's just follow the pipeline here. We have load 3D model, current address. Current address right now is your loading area on the work RAM. Well, where does it go? Where is current address at this point? Oh, this, okay, so you start it at, oh, you started at low work, okay, so beginning of low work RAM, because you're using the end of low work RAM as your loading area. So this is actually the permanent address. Okay, I get it. So yeah, that start address is an actual real address. I assume at some point you'd want to automate that by just tracking have like a table of sizes, entity sizes and locations. Right. So, real quick, before we keep going, these sort types, they're enumerated. Is that part of SGL or is that part of XL2 stuff? Where is it enumerated? Because we don't say 0, 1, 2. We say sort min, sort max, sort sen. Or is that somewhere in the render code? Okay, so I'll say that. Okay, sort min, sort max, mort max, there we go. Sort sen. Go. So model data T, this is... Okay. Yeah, it's a better way of saying that. SL def.h. Do you have a modified SLDef in this file somewhere? I'm guessing in you have your own copy of Joe Engine in this folder that you have from your GitHub. I have to remember to link your GitHub onto the backup for this stream. Let me go ahead and load it up in chat too. Let me see if I can get. Oh no, I had it open and I closed it. Crap. No, it's not there. Ponut64 GitHub. Have it starred. There we go. Okay. So, Okay, where is oh, there we go. There's Twitch. Yeah, that's what I figured. So, if you go and download Ponut's stuff, literally go and download Ponut's stuff, you're gonna find inside of, well, he doesn't have this display code exactly, but I guess I'll talk him into uploading that, or I'll upload it myself if he wants me to. We can go into Joe engine, and then there should be under Joe, I assume, is an SL. No, where is it? Where'd you go? Is it? No, where is it? Come on. I got SGL prototypes. Where'd you put it? DDB2? No. PSP? Definitely not. Compiler? Probably not. Wait, actually, maybe compiler. There it is. Under compiler, there's SLDef. From SGL 302J or something. I don't know what that means. Some version number. Not that they're coming out with any new versions of SGL anytime soon. Okay. So this model, do we need this line? Can we comment that out, or does that actually get used? Model header? Looks like it does. Okay. So model data, I assume, is a struct that you... Here we go. So this is essentially struct containing model metadata. I don't know what this comment is referring to. Okay. Memory address to begin right. Okay. Now, what are these guys doing? I don't even know what type this is. GFSHN. That's one of yours, or is that from SBL or SGL or something? Got one too many lyrics in this thing for an instrumental version. I'm gonna take it off the list. Okay. So what is this? SBL data type. What's it doing? So GFS is something to do with the file loading system, but what do we use it for exactly? Where does this come up? Okay. General file system handler. But what is GFS mdata? Is that more metadata? It doesn't... It's getting whatever GFS open returns, which I thought was just a boolean. What are we storing in there? And how is it going to be useful? Okay, so it's just required for loading. Required for loading file. Okay. Because I don't think I store anything like this whenever I load a file up with GFS. I just do it, throw away the result. Okay, well, whatever. Yeah, take it. We have a sector count and a file size. These are largely more file metadata. Name to ID. Get file size, get file info. I'm not sure what this file info does, but this is just part of your part of just loading. So we're gonna this closes the data stream, right? Which means we've already loaded the file as GFS metadata. So this is holding. This is holding all of the data for it, is it not? So we've opened and closed the data stream. Where did we store all that information? I think it's supposed to be in here. Oh, is it like on chip? Like it's part of that SMPC or whatever's doing the loading. Whatever chip controls the CD, that's what's doing the loading. So we've stored all that into some sort of cache, and we're just grabbing stuff from there before we open and close a new one. No, I'm not talking about get file size and get file info. I'm talking about this variable itself, gfs_mdate. I'm assuming that is holding. Oh, really? That's weird. Open file using GFS to retrieve metadata. Close the file. Wow, I can spell. And now we have GFS load. And we're going to actually load the file into work address. So all of this is just for metadata. Basically all this stuff. Just to get the file size and the sector count. Wait, what's the sector count for? Is that you need that for loading it off a CD, but you don't even... Well, I'm sure this thing gets it, but... Yeah, I mean... Well, I mean, that's why Joe Engine basically writes a wrapper around all this crap so you don't have to think about it, which is nice. So if it's not used, what's the point? I mean, okay, whatever. Just a dummy variable to send in as argument. I don't know if we're allowed to send null in its place, but it's not. It ain't broke. Need to fix it. Okay, so now we're actually going to load the file into work address using the metadata to tell us how big the file is, so we know what to do. Local name has already been set as name to ID. I'm not really sure what the purpose of that is. Whatever. Well, I mean, I guess it gives you some CD disk location or the equivalent thereof, I guess. So copy memory from model header into beginning of work address. Source destination. Oh, copy memory from work address where file is currently loaded, and write header, right, model header data as is up to the size of the model data underscore t struct. So that means we have our first piece of information about the file format that we can document, which is why I got Excel open on the other over in YA. We have our, I'll just do, I guess, our byte, and then our purpose, and then our equivalent address, or not address, equivalent variable. I'll swap these two. I don't know if this is too small to see on screen, but whatever. So we know that the very beginning of the file should be model data underscore t. You know what? You make an excellent point, and since I already have this thing open, I can just go over here. So, in addition to this display code that's meant to be run on the Saturn, we also have this exporter code that Ponut gave to me. It's still labeled as write ZTP, so it's a ZTream format. I'm assuming this is the updated version, and he just left the name as is. Yeah. Okay. Oh boy, this is also not commented. Okay. Normalize, f dot. Was that first thing the one to look at? No, there we go. Write SGL P data. Point empty 4-byte area for point table plain table. I don't know what that stands for. Which function do we want to look at? There's right textures, normal lookup, calculate normals. Okay, first function was a header. Let's use the first function. Oh, interesting. Neat. Okay. So we use 2 bytes for the number of meshes. 0 to 1. We zoom in a little bit. Number of meshes. So wait, what do you mean by number of meshes? I'm not sure if I understand how many. By meshes, do you mean, is this for animation support? Okay, let's look up the equivalent part of the struct where that would come up. This is model data underscore t dot total mesh. Oops. Okay. So we're going to be mapping out this format so we know exactly what it looks like. And that way, if, say, we wanted to write our own converter in a different language for a different tool, we know exactly how to put things together. What do you mean the size? The size of what? What do you mean by size? Because it's not an unambiguous statement. Okay, well, for the next one, from 2 to 3, we have number of textures, and that's a little bit more easy to understand. We know how many Would you stop that? 2 to 3 does not mean a date. Okay, first off, this is a number. No, it's not a number, actually. It's text. Text. There we go. 2 to 3. So, number of textures. Why can't I ever spell? Okay. Hot text. Okay. It's not a very consistent naming scheme, but whatever. Would not have gone with text either. Total size of pdata plus compressed vertices. Why can't I... Is this read-only right now? What's going on? Oh, okay. Why can't I see... Oh, this theme is not good for me. I need to know where I'm typing. Real quick, let me just change something real quick. Editor. Go. Let's do dark gray. Okay, there, at least I have a black line. That's something. You can change the color of that to white, I don't know. Anyway. So, compressed vertices. Compressed vertices are not as fixed, but as some modified version of fixed that takes up less size, correct? Probably always 1. Let me go ahead and save this as, well, let me put this under great value. Go. Ah, fine. Now I'll just call this great GVP map. There we go. This is from 4 to 7, I believe. No, wrong one. Go. Don't do this anymore. And then from 8 to 11 is total size of textures. And pass on this one. Okay. So actually, let's go back. I forgot. We need data size and text size. Eight to 11. Currently unused. But whether or not it's used is I'm not going to say it's immaterial, but right now we want to know what's where, even if we're not using it. Yeah. So right now we're just making the map, so we know exactly what's going on. Oh boy, we're running out of useful stuff. So 12 to 13 is number of keyframes. Number of keyframes for animation. Is that in here? NB frames. There we go. Model underscore dot. Guessing animation struct. Gonna be next, and then I'm probably gonna be wrong actually now that I think about it, because frame rate with 2 scare quotes around it. I don't know what that's supposed to mean. It's 14 to 15. We can get rid of that. $16, $19 actually. And then 20. Well, like I said, it doesn't matter if it's unused or not, I just need to know that it's there. So what gets written there? So right now we're just making a map of this format, just so that, you know, there's one reference, so you can open it up and see, okay, here's what's where, and here's what to use inside the model. So if I know I'm gonna need this for here, if I know that my model data underscore t struct, I'm going to want to use this thing. When I build a converter for it, I need to know to store that relevant number there. The number that I would have used as the total mesh number. Okay, for an example, I'm actually going to use for the p data size. I'm going to have to calculate inside of my converter. So we're building a map, long and short of it. So, you have number of keyframes. 12 to 13, 14 to 15 is the frame rate. In scare quotes, is that frame rate as a sync constant or is it its own number? Is there not an equivalent to that? So is this frame rate like... why do I keep doing that? 60 divided by SL constant. Actually, let me see what actually would be the relevant thing there. Or is the frame rate different? Is the frame rate like that frame time that you were calculating earlier as part of your heuristic? Okay, so okay, let's say they can only be at 30 FPS. Does that mean 30 is stored here or 2? Again, not the fact that it's a useless value is not the point. The point is I need to know what would be written here for consistency's sake. Here, for just one moment, I'm gonna be back after about a minute or so while Ponut looks up something, and I just have to use the restroom real quick. And just go ahead and mute my mic. Okay, so let's, for future's proof's sake, not implemented. Let's say that we will want it to be the equivalent of SL const, but it's not implemented. So this is frame rate, or animation frame rate. Animation frame rate. Frame rate. SL const. Or SL sync. Equivalent. Currently always 0. Okay, and then we have literally nothing and blank, which, does it end at 20? It is, so this is 21 bytes, but the last 6 bytes or so are blank. Is that what that means? Just looking through here real quick to see what's actually in here. You're right. Okay, but here's the thing. So this is a 4 byte. So this is currently, 4 bytes of 0. What about number 20? Is that the same thing? Is that just 1 byte of 0? So do we have like a return character that's written there? You don't know? Okay, good. I see a new line, but that's going toward the it's going toward the printout. It's not going into the file. So this is write media. It's going into the file stream. So the file stream, we have, okay, count size, number of frames, frame rate, and then is this Let's ask Wolfram how big this is. I don't know if we want to bother putting a terminating character in there or not. I don't know if it's necessary. So it's a 16-bit integer. This is... No, wait, no. Okay, let's try it this way. Let's replace each one of these with an F. Oops. Insert does not work. F. Okay, that actually helps. I think I just... Okay. So the last 4 bytes are 0 as written by Right U in 32, as Faith42 has pointed out. Okay. So that's the map. That's currently the map. This is the header. Let me color code that. So header is, I guess, light green, lighter green, lightest green. Lighter? There we go. Header data. Now let's start doing, what comes after header? There's the metadata. Where's the actual... Okay, so after that comes... Write model binary. Textures, data, animation. Write model binary. Okay, we write the metadata. Then we write SGL pointer data. Okay, I was at the right place before. Animation, textures. Okay, so we go after the metadata. We go SGLP data. Comment above that function. Okay, so wait, where is it? Where is it? There we go. Header, P data, animation, if present, and then textures. I don't like the inconsistency of this approach. I would prefer it if we have all the textures ahead of time. I feel like we should have... The P data is just a list of vertices, right? So we should have the most consistent things down to the least consistent things at the end. The optional stuff should always be at the end, I would think. So header, and then I guess P data for, you know, all the points and all the vertices essentially, and all the normals and what have you. And then after that I would put textures and then animation data if present, because the animation data, I guess the animation data is in a similar class as the P data, as it's just numbers as opposed to images. Oh, really? Okay. I can see that functionality. So if we have no animation, what do we write? Do we just not write anything? Or do we like put like 1 or 4 bytes of 0? Nothing is written. Alright. So P data. It would help to make sure we know how P data is structured. So, actually, let's go to the P data struct. What's that under? That's going to be under SLDef, right? So we go into compiler. Included ZLDEP, I assume. There we go. All right. So here's, oh, this probably should have been Japanese, but is instead garbage because, I don't know, text encoding stuff. Save that. Yeah, those were supposed to be Japanese, but I don't think I have the Japanese text support in Notepad++, so it's just garbage. But what I care about is this P data, because we are writing this as the next part of the map. So I'm going to write P data as, I don't know what color I'm going to make it. I'll figure it out when I'm done. So my issue here is that these guys are pointers. So what a P data is inside of here is different than what's getting written as P data here. Isn't it? Huh. Weird. So, empty 4-byte area for pointer table pointer. Okay. So let me go ahead and write that. So this is point table pointer. So P data dot this. No, wrong highlight. Quit that. This should, if anything, this should be light blue. There we go. And this is 4 bytes. This is 20 to 23. Zero in file overwritten by address in engine. You quit that. Ain't buying what you're selling there, Green. Okay. Number of points. Oh, okay, MB point. Doesn't that feel redundant? I feel like we can get this thing to be a little less redundant, but whatever. No, I guess it's not, because... Huh. Oh yeah, whatever, yeah. Sure, fine. Okay, so that's number of points is that's going to be 24, 5, 6, 7. NB point. Sure, I wrote that down wrong. NB point with a capital P. And then number of points. Why? No, I'll fix it later. Point. I guess, what are we calling this? A point table? All these are just 4-byte addresses, I guess, or 4-byte writes. So what's next? Another 0 for poly table. Polygon table. There we go. So then that way we have PLT. Okay, this is PL as opposed to PN. And we're gonna have 32 to 35. Okay. This is actually number of polygons. Number of polygons. Why is it automatically going green? That doesn't make any sense to me. It's NB polygon. All right, so it's not redundant in the file yet. It's just I don't like this bit, and I don't like the fact that we have this, and it's not really doing that much for us. But what's like a handful of bytes anyway, as long as we can read it. So it just makes it easier to just copy memory from the file as opposed to writing it specific places. Sure, fine, okay. Attribute table. Okay, so that means this last bit is also zeros, but pdata dot still 4 bytes, so that's 36, 37, 38, 39. Oh crap. And this is attribute. Is that what that stands for? Attribute? Alright, so now we got that, and that's our P data, so what comes after that? Oh, 12 bytes per point. Is that our compressed address? Why 12? I'm trying to think, because it should be 4 bytes times 3, right? This is 40 plus, let's go ahead and write this out. To number of points times 3 points number of, let me write this explicitly, number of points times 3 dimensions times 4 bytes. Okay. Try to zoom out a little bit on this pointer table. Hopefully it's still legible. Oh, is that readable on a normal screen? I feel like this is kind of pushing it a bit, but it's probably fine. And this is the equivalent of what? It's not part of P data, it is the actual value of the pointer table. Oh, crap. I think that's accurate, right? Okay, I'm just gonna write up the sizes now. I'm gonna make descriptions of size in italics just to make it a little bit easier to deal with. This is each point, or each call this vertex coordinates with 4 bytes per dimension. Okay. And then polygon, and then 12 bytes for normal. So, wait. So wait, is this a polygon? These polygons should be descriptions of polygons, and then do we also have normals? What's going on here? Okay, so we write a normal and the list of vertices. So is it 2 bytes per vertex? Yeah. Right. So we define a normal, and I assume that's much the same as the other guys. It's 4 bytes per dimension. And then the vertex indices are 2 bytes per, correct? Or not? It doesn't look like it is. It looks like it's oh, it is 2 bytes, 16. So this is... Okay, this is going to be a long description. Number of... Number of what? Polygons. 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 Times. Oh, this is going to be a long one, too. First thing we're going to have is 1 normal times 3 dimensions times 4 bytes. So let me copy that from over here. Plus 4 vertices times 2 byte index. There we go. So this is normal, basically polygon data with normals. So here's the thing, though. You are currently using the a color mapped approach, right? So the easiest and most straightforward way to get something out of Blender is using the RGB approach. And in order for me to even consider doing the other thing, is that I'd have to figure out a way to get Blender to automatically generate a color map, some sort of palette or something. And then we'd have to make it compatible with the way you're doing it. So that means I'd have to have Blender generate the palette, and then also from that palette, make sure it's written in a way that's compatible with the thing that we had GIMP export. That's gonna be a job, but I will. That's gonna be my next big project, I guess. And oh, let me see. Okay, I mean, we can do that too. Actually, that's probably a better idea now that I think about it. So that means Blender would have but you'd have to make Blender do image processing. I think wouldn't it be better to have whatever textures we have? Because you have to give Blender the textures. Wouldn't it be better to have the textures already conform to those things? But then you'd have to have Blender still understand what a palette code is, so you still have to feed it in. The problem is, I'm sure Blender is capable of doing it, but it requires reading a lot of Blender documentation. I'd essentially be becoming a Blender dev at that point. Hey, Wokey! No. Okay, I haven't been on PSO in a long time. I've been very busy, so sorry I haven't been around. But it's nice to see you on stream. Yeah. So, the Saturn needs the palette, and ideally, you'd feed the palette into Blender and it would know what to do with it. The palette's already in RGB, so Blender can probably easily read it. The problem is figuring out a way. Oh boy, it's hurting my head even thinking about it. We'll get to that when we get to that. I just installed my USB GD ROM, so my Dreamcast is actually... I haven't been getting a lot of use to it, but I've been doing a few test cases just to see how it's going. Here's the thing. That would definitely make things easier, but how much RGB stuff can you fit in memory before it starts becoming a problem? I mean, I learned to adjust to it because it made me fitting more stuff in memory a lot better. Like, I can fit so many sprites and so many animations in memory now that it's just nice to have. So, 240,000 pixels total, is that with RGB or with color mapping? Because remember the problem that Cobradal had when he was starting out with his game, is you have to look at it from the perspective of someone that is expecting it to work like a computer, where you load files and they work. Cobradal didn't have all that many pixels to his game. He had maybe 1 or 2 full screen images in RGB, and the rest of them were just large but otherwise reasonable sized sprites, and he still ran out of memory. So is that Joe Engine screwing up, or can he reliably fit those guys in memory and not have a problem? Because then, if we're relying on RGB the whole time, yes, it'll look nicer and it'll be more consistent, but then we'd have to do a lot of loading and unloading, I think, all the time, which is not completely desirable. But that 240,000 number, what do you mean by that? 120 64 by 60. That doesn't feel like a lot. It really does, because if you think about all the textures you want on a level, plus how much detail you want to put, basically you'd have to decimate everything down. You'd have to put it like as a 32 by 32 or even worse, 16 by 16, which is, at that point you're pushing verisimilitude with like what you want to be able to see in a 3D environment. $60. Yeah, it's not a lot, which is why I liked the idea of using color maps. However, here's what we can do. Exactly. Yeah, it'd be like, you remember Bug, right? Like, essentially Bug was a background image, and then a whole bunch of like really simple cubes and ramps with the exact same texture, and a handful of enemies. And that's all you'd be able to do with this, because if you only have 60 textures... Here's the thing. Starting out, though, we have all this empty space. We can put a flag in here that tells us what kind of color map, or what kind of render path we're using. So this 16 to 19 bytes of nothing, we can say 0 for RGB, 1 for color tables or what have you, 2 for color. Okay, wait, 2 for color lookup tables and 1 for like palettes or whatever. Highlight my message. What even is that? What's a highlight my message? What it? Okay, so yeah, color lookup is, but that means we have to code it in. That or, oh, this is a terrible idea. In the loading function, well, here's the thing. If we can code it for the Saturn, we can code it for Blender. It's better to code it for Blender. So, how about we do this awful manual way, where we tell Blender to give us an RGB, which I'm pretty sure we can already do without too much issue. So we have Blender give us an RGB, but still in Python, we go and take all those colors and find nearest neighbor to the color lookup table that we've uploaded. And then we just shove it in that way. And if the color has a big enough alpha channel, we just set it to color 0. It would probably be a very slow process, because it would be processing each texture that way. But that way, you don't have to worry about optimizing the number of textures you're using per face. Every face can be UV mapped, extracted as RGB, pre-calculated in the exporter as some sort of color lookup table thing or color mapped thing. And then by the time you get it in the file and you load it up, it's already compressed into that index color format. So the more I think about it, the more I think it's doable. It just sounds like a huge pain, but I think we can do it. But I think initially we should try to set up the render path for RGB just to see if we can get proof of concept. Just have Blender crap something out and pop it up on screen. Yeah, so we can just replicate what XL2 did then. I don't know. What do you mean you do things different though? How are you rendering your stuff? Well, yeah, but that's good for an initial test, but it's not fantastic for. Well, yeah, you got to start somewhere. So yeah, let's. I think it's pretty obvious at this point that I'm not actually going to get to the Blender part tonight, but I feel like if we can just map things out and figure out what's going on, then we have a road and we can start thinking about what needs to be done next. See, so I'm used to the color RAM. I can understand that now because I've been using it for Forsaken Plane. Every time he says CLUT, I don't have a good idea for what makes that different from the color RAM palette approach. From what I can tell, a color lookup table is literally just a palette of colors that you look up with an index, which, to my knowledge. But conceptually speaking, what is the difference, really? Because if you have something in color RAM versus something in VDP1 RAM, it's a different location, but the job is the same, is it not? It's taking an index and retrieving a color. Okay, so it's the different display modes that have different capabilities. What's happening there? All right, so I need to read the VDP1 manual. Okay, so with the color lookup table, you can get your basic texture done, but then you can use lighting effects or something in transforms, and you can change the way it looks. You can still do fancy things with lighting, which is what XL2 is good at, what he's pushing his engine to do. How big is a color in CLUT versus palette? Oh, it's just the amount of memory you're using. Okay. I thought everything was in standard RGB 4x3 lights. I like the idea of using color RAM because it's already a designated space just there, ready to be used. But my proposal is that these 16 to 19 area, we can just designate the first 2 bytes of these things. Say 16 to 17 is some number that tells us what kind of display mode we're using, either RGB, color RAM, or CLUT. But that means there'd have to be 3 different render paths written, and I don't know if that's a reasonable request or not, or feasible. Okay, let's keep mapping. So we have the polygon, we got our normals, we got our vertices. I think we already described that. Now the attributes. Okay, so each texture has a maximum of 16 colors, which isn't really that restrictive at all. But then I'm comparing it to Forsaken Plain, where I definitely have more than 16 colors per sprite, depending on what I'm doing. Actually, now I think about it, I probably am too lazy to use... Like, every sprite has the ability to use more than 16 colors, but I don't think it actually does. So I guess, from that perspective, yeah, that still works. So you got more colors total, and you just write a color lookup for each sprite. So if each of them has only 16 colors, and each of those textures is, what, 64 squared? So he's compressing his RGB... I'm assuming it's 64 squared. It might be 32 squared. $64 color. Right. Here's what I'm trying to figure out is how much space is being saved. So with RGB, if you have 64 by 64, you've got 4096 times 12 bytes. So you've got 49,152 bytes. Just keep that number in mind. If you have 16 can be expressed via 1 byte, unless he's compressing that even further. But let's just say 2, 4, 8, 16. So that's 4 bits. So actually, he can do 2 pixels per, which is, I think, already in the manual. I'm trying to calculate how much information he's compressing. So every 2 pixels is 1 byte. For XL2's approach, he's using color lookup tables. 4 bits per pixel. Yeah, that's what I just figured out. So 1 byte is 2 pixels. So if he has 64 times 64 divided by... What is it? 64 times 64 divided by 2, he's using 2048 bytes out of... What was that massive number? 49,152 divided by 49,152. So he's using 1/20th of the space, essentially, using color lookup tables for each texture, which is why if he's allowed to use so many freaking textures. And then the CLUT itself is just going to be 16 colors times 12 bytes per color, 192. So what was it, 2048 plus 192 divided by 49,152 or whatever that number was. Yeah, it's still less than like 4.5% of the size he was using. So yeah, it's a really smart way of doing it. Maybe we should replicate it. I don't know if it's within my... I don't think it's within my skill level. It should be a lot more than 240. Based off the math, it's... If for each color lookup table, along with an associated 64 by 64 sprite, you should have 4.5% of the space taken up, including that color lookup table. It can't be less. No, that doesn't make any sense. So with RGB, if you have 12 bytes per color, times 64 times 64, 49,152. Oh, RGB is 2 bytes. Crap. Okay. So, so it's times 6. 64 times 64 times 6. Oh, it's two. Okay. Oh, yeah. Okay, so it's half. So are you saying the entire RGB? Yeah, 64. So 64 times 64 times 2. You're saying the entire color is stored as 2 bytes, right? Okay. Right. And then for the color lookup approach, it was a little over 2,000. Should be 4 times multiplier. A little less than 4 times. So yeah, a little less than 240 is correct then, if it's really that small in RGB. That means the colors in the color lookup table, are they bigger than in RGB? Huh. Well, I think we're getting distracted anyway. Let's Let's get back to trying to figure out what this attribute is doing. Well, the bigger the texture that you use, the more space savings you get with the CLUT. So I think sticking to 64 by 64 examples is more ideal. I don't know that there's any benefit to doing a 128 by 128 texture, though. I think 64 by 64 is plenty. Actually, 32 by 32 might be sufficient, considering the screen resolution. Yeah. But you can fit so many of them. Yeah, okay, yeah, 32 by 32. I'm copacetic with that approach. Okay, so for the attribute, he's writing... What is he writing? SGL attribute. That's another struct that we need to... Is this like a sprite attribute? Or a normal attribute? I wish these were in English and not in garbage. Oh boy, okay. So if we go by what's happening in here, we are writing flag sorting text number. So flag sort text. Okay, yeah. So this is this attribute here. Let me go ahead and write. Color these guys in. Oh, come on. Don't connect to anything. Dot flag. What does this flag do? He's writing 1 byte here. Or 1 char, actually. No, the sort should come after that. He's doing the sort right here. Here's the flag. And they're both written as chars. So, the thing is, I don't know what flag and sort do in terms of the attribute. But I think we can look it up in terms of... where is it? Documentation on the SGL reference. So let's look up the attribute. There we go, face attribute list. So this is front/back setting. Wow, that doesn't help at all. What does that mean, front/back settings? Is this have something to do with backface culling? What is it? Rather me. Oh, Okay, so dual/single plane mode. So if true, does it set it as dual? Okay, so it controls backface culling. Okay, yeah. So enables backface culling if true. Does that sound correct? And let's go ahead and color these in as attribute data can be orange or whatever. Then we got our sort. Sort. And according to the reference, sort is sort setting. So that sort setting, is that sort min, sort max, sort center like we described earlier? Okay, so flag, sort, ATRB, and directory. I'll just flag to see which ones are active and not active. Only red for first polygon. Which means we're storing a lot of single byte information that we're not using for every additional polygon that we have. So what's next? Next should be number of textures, which now we're getting to the redundant stuff. Next number. Number of textures. So you went 16, that's 2 bytes. Oh, no, that's not number texture, that's texture number. Yeah, okay. My bad. So everything after this is uint 16, so. Oops. Okay. Okay, text number. So this is all in the same order, right? Attribute, call number, GST, directory. Attribute data, ATRB. Oops, like, where am I? Attribute data. So what does this do? It's currently not used, correct? Given polygon. So what's the mesh enable bit? I don't understand what that does. So does that allow it to just appear as that cross hash pattern or? Okay, mesh transparency. So attribute data controls mesh transparency and shadow effects. So wait, the way this is writing this, is this looping through something? Or this is number of polygons? Let me insert a loop level. Per polygon. There we go. Now we know what's going on. So each polygon is being fed in its own attribute data then. So what comes after that? So is that color number? So how do we use that? I know this thing somewhere in here has information concerning the ATTR struct. There we go, 7-2. As soon as I get there. Oh, there, I was just there. Okay, indicates the color data. Okay, so I'll just call it currently unused, but in practice, in SGL, what would that correspond to? Okay. GSTV. Go rad setting. Indicates color bank in palette code mode. Color in polygon / polylines mode indicates color rank in palette code mode. Currently unused. Okay. Fair enough. Okay, well, then we'll add that to the end. So wait, what? So is this specific attribute? Is this part of the attribute used in CLUT mode? Okay, so CLUT pointer in 4 bits per pixel. That'll be good enough for now. Okay, we got go rad setting, and then what's the last bit? Directory. Or it's not directory, is it? What does it say? Texture reversal setting and type. I'm actually not sure what that does. Which bit? Wait. The color number bit? Yeah, from what it sounds like, you kind of have to, right? Flip. vert slash horizontal. Okay, so you assume the color bank, or I don't know how you do it. Okay. And that is SGLP data. So once we're done with SGLP data, okay. Duplicate base data array of the model's vertex. So recopying, what are we doing? It looks like we're copying P data again, but it's just in the number of models we have. Oh, okay. So we're jumping straight to animation. All right. So how big is an animation? Let me see. We have keyframes.cvert. What's the equivalent inside of this thing? We have an animation struct that we can point to. Is that XL2 stuff? There we go. Let me go ahead and copy that down right now. Okay, so yeah, mloader.h, which I'm in, has animation struct. We've got comp vert and cnorm. So how big are these guys? So these are both 16-bit times 3. So that's 2 times 3. And this gets looped per mesh. Let me see. Gotta figure out this loop level here. So the first thing we have is we have a no, we don't write that. We have for number of frames, for number of models. I don't remember that coming up. We're looping over it, so we need to know. It's the number. How many times are we doing this? But where does the number of models come in? So we have a model. Let me see if we can find out where that's defined. I'm sure it's somewhere in here or the related header. It's an animated model T. Oh boy, this looks... Did he literally just shove in SGL in here? I guess he could, so yeah, he did. Are you sure? It doesn't make sense for it to always be 1 to me, but let me see. I think we're done writing the P data for SGL. Yeah. Pulls out of that. We have to be able to... For some reason, I feel like this should be per polygon. We write the animation model. Being passed in. Okay. So we are passing in an animation model. And it's getting looped through by number of frames. And then we write... Well, for the number of models, we write... a pointer table. This is a little bit arcane. So, loop level I is number of frames. That's pretty straightforward, however many frames your animation has. Then we got a secondary loop level, which is, from what I can tell, the number of models within a single animation model. That doesn't make sense to me. Okay, let's call it always one then, right? Yeah, that's the problem. Is I would love to keep using whatever XL2 is written, but he's made it clear that he's planning on slowing down his work once his current project is done, and, you know, doing some personal life stuff. And also that he's not planning on sharing the final version of Project Z-Dream. Meaning we're kind of... Well, Ponut is doing all the heavy lifting here. Ponut has to kind of, like, work off of whatever the last thing that XL2 gave away for free. Which I believe this is just whatever he was using during Sonic Z-Dream. And in the meantime, we're trying to divine what XL2 was doing without comments over here, which is why I'm mapping everything I can so I know what's going on. So let's say the number of models is always 1. I would love to know where a model is defined so I can look up what's going on. Saturn Def looks like it's literally just copying over the SGL definitions, and I'm fairly certain a model is not anywhere in here. So I'm going to close out of this. Okay, common at H. So at the very least, we can see... Oh boy, why is... You have to define pi? I thought that came with C++. Oh, I guess not. Okay, whatever. Weird to me. Where's a model? In there somewhere. Animated Model T. Okay, and we're looking at number of models. Does it ever get written anywhere? Okay. I'm gonna go ahead and believe you, Ponut. Let's say this is always 1. This is no longer loop level. So the loop level is per number of frames. And for a number of frames, we have to write... What? What are we writing? The entire A model. Holy crap. Okay, so now we got... Let's go over to write A model. Where's that? Here, the thing that we collapsed earlier. Per keyframe. That's our loop level now. I'm not sure I follow. What do you mean by it does, but it doesn't? Why are we writing... It looks like we're writing 2 blank 32-bit integers. No, it's not blank. It's... What? In... What? Oh, yeah, pi. Right, okay. Swap endian signed integer frame ID. So... Frame ID... Why do we need to swap the endianness of it? How does that help us? Okay, here's the thing. If I write a converter and I don't at least make enough room to figure out what's going on in the animation system, there is no animation system. So the exporter does nothing. That, or you rewrite your format or your standard around whatever animation system you want to use. Which I'm all for, but I need to know where things are. Okay, yeah, but if I'm gonna make any headway on doing something, like, ideally, what I would like to do is take the Blender file for your pony, click a button, and just have it work. Right. So maybe we can go back to the Saturn code and see how it's reading in that data. And how it's, I imagine you're reading in something like this, an animation struct. It's part of an entity T, so you have up to 240, and holy crap, 240? Jesus. Okay. I mean, for now, if you wanna say, yeah, we've accomplished enough today, what I would love to do is I would love to, I gotta think. I think if you don't mind, I would like to redesign this file to reorder some things to make things make a little bit more sense, and also change certain pieces of metadata. So here's what I think we should happen. We got a bunch of blank space up top. We could either get rid of it or use it for something. What I want to do is I want to store in the metadata the number of bytes. Well, we already have pdata size, right? So we know how big this area is. Do we have attribute? We know exactly how big an attribute is. So we know how big this thing is. So with pdata size, we know how big this thing is. We know how big the textures are, which means the area that's going to be down here that's going to store the textures, we know what they're going to do. I say that we just have an additional flag that's in between these two that says animation size. And it tells us how big this thing is going to be. So for now, we can just skip it. Oh, okay. So pdata size is going to describe all the blue and the orange on this chart. Okay, it's inferred, but how big is it really, though? So per keyframe, let's just leave a placeholder here. How many animation structs? We have number of keyframes animation struct. How big is an animation struct? Oh, where did I leave the animation struct? There we go. Because they're two different, they're just two... If they're two, three element, sorry. They're two 3-element items, okay? One of them, the norm is for some reason compressed to 1 byte per element. The vertex is 2 bytes per element. So, just real quick, we can just say that's going to be 6 plus 3 is 9. So we know it's going to be 9 bytes. So it's well, here's the thing. If you're doing it as it's the number of frames, meaning we're not interpolating, that means it is a number of keyframes. In this case, you only animate keyframes. So the keyframes are your frames. It's 100% keyframe. There's no interpolation happening. I know I'm kind of torturing the vocabulary here, but okay, wait. Where do we keep that? Oh, it's not here. It's not in there. Crap, where am I? For points? There we go, number of frames. There we go. Right ZTP. Yeah, so we loop over number of frames, but those are the frames in Blender, right? Those are the keyframes that we define in Blender. Look, it's the keyframes we write in Blender. So XL2 was saying that he's not doing interpolation anymore. He's just explicitly writing every animation frame, which, you know, good for him. That means he's got that many keyframes, right? So he's defined on that little Blender timeline down there which I'd pull up if I had, but I don't, and I'm not going to try and remake it, that we have, let's say, what's his animation frame rate? Probably, let's just call it 30 for now. I mean, he's got, for 1 second's worth of animation, he's got 30 frames. So if we know that this character model is going to have like 40 frames of animation, like his Sonic, I know his Sonic character model had like 40 frames of animation. So it should be 40 times those 9 bytes. Are you serious? I don't believe that. No. No, that can't be right. That doesn't make any sense. P data is P data. It's completely separate. Animation data is XL2's custom thing. That would be... Oh my goodness. Are you serious? So it's absolutely worthless. No. It's named wrong. Why is it named that? Okay. This should be total size of P data plus compressed verts plus animation plus attributes plus everything else. So just the total size of the thing, which is, why do we need that? But okay, it's there. Oh, compressed version. Okay. Well, compressed verts is the animation. Does this also include the attribute data from down there? Yeah, I assume it does. Right, okay. So, my suggestion is that we have one number that is this, and then one number that is this that we can multiply by this. And then we have another number that's just this, so we can skip over it. Yeah, okay, yeah, I figured. So no, I feel like it would be very easy for us to just insert some extra metadata that just tells us where all the stuff that we care about is, like what address it's at. Oh, hi. I don't recognize your name, Dr. Spod? Doctor's Pod? Are you a married couple of 2 PhDs, last name Pod, or one Dr. Spod? Throwing me off here. Anyways, well, while you introduce yourself, or don't, I don't know, one of the two. Just one doctor, so it's one doctor pod. Or it's a doctor possessive, and you own a pod. Still trying to figure out your name. Also, do I know you from Sega Z Stream? Sega Extreme? Do you have like a different name that I might recognize? Are you from the Facebook group, maybe? I don't know. Oh, you're just new. Okay, well, welcome to the stream. You're welcome to chat here as much as you like, because we're all going crazy trying to divine some uncommented code from XL2 from, I'm guessing, like, almost a year ago that this got forked off. Anyways, so while we're here trying to map out this... here's the thing, Ponut. What we're really doing right now, we're not mapping out GVP. Because GVP can be whatever you want it to be. We're mapping out ZTP. And we don't have to, because that work is already done. What we want is to make a thing that is maintainable and expandable, and I feel like adding some metadata here will help. And maybe we can think of a new way to do animations that will make sense to a human being. So I know the last time I looked at animations, I somehow got it working, but it still was like an hour of me commenting stuff and half understanding it, and by the grace of God, it worked. Yet it still works. I mean, it works. I mean, if anything, I'm just gonna fit in the told you so of always comment your code, because even your code, it lacks the comments that it probably needs. However, right. So we have all this extra stuff that ends up getting calculated, I guess, or written or something like that. I mean, the doctor and his pod have a point. We should be coming up with a file format that makes sense and is expandable, so that if you want to add something to it, you don't instantly break it. So here's the thing. We've already broken ourselves on animation, but let's assume that we're doing so it's going to be a both of these are triple vectors. First one is 3 times. Here, I'm just going to change the language here to stop bothering Ponut, because I know that there is a difference, and let's just call it per frame for now. So we have 2 bytes uint16 times 3 dimensions plus 1 byte sint8 times 3 dimensions. All right? That's all of our animation. Looped over frames. That's what I can tell is happening. Let's move on to textures. I would feel so much better if we could just move on to textures. Because I know for a fact we're going to go crazy doing anime. There we go. Write textures. Comes right afterwards. Let's write textures. Where are you? There. This should be understandable, right? So what's he using right now? Is he using RGB, clut, what? For the number of textures that you have, we write a model texture I. Oh boy. Okay. Where did he keep that? Oh, it's in common, right? So an A model is an animated Model T. Animated Model T has texture I. Texture I is a table of textures. Oh my goodness. Wow, this is just recursively expanding into bigger and bigger things. What? What they do, they tell the user what's going on, which is a good thing. You want the user to know what's going on. You want comments. This is kind of like having a comment, except it's on the command line as opposed to inside the source. Point is, this is a whole thing. Okay, so we go into the animated model, and we find out the number of textures. From here, okay. We have a number of textures. Oh, not that one, that one. Okay, we have the number of textures. That's how many times we're looping. Loop level is number of textures. Good to know. Okay. Per texture. Color this a little bit different. This one can be actual orange. The other one's yellow now. So we write this number to file. What is that number? Oh my goodness. Okay, so it's a bunch of ones except on which digit? 1, 2, I'm in here. There we go. 1, 2, 3, 4, 5, 6, 7. 7th digit is 0. Everything else is 1s. Is it, though? How can that possibly be true? Why would he be writing the number, well, whatever it was? Why would he be running? $15 digits, so that's 16-bit. So for the next 2 bytes, some number. Animation struct. Okay, so it's just some number gets written. 2 bytes. Yep. Okay. Well, wrong color, but there. It's just a 2-byte boundary. But why is it that number? It doesn't make any sense. It has to be... You could have just put zeros there if you really wanted a boundary, which you didn't do. I assumed because it's just a whole bunch of 1s and then 1 0 in a specific place, it was just a list of different commands you can send to VDP1 to draw something, like a bunch of different flags. Some sort of command code duct taped together. Okay, yeah, it's literally nothing. Okay, now we're writing height and width. Height and width are unsigned integers, which I assume these are 4 bytes per. Then you. Okay, so how are you writing these? Are these... Is what I'm writing here different than what you're doing? Because I want to be doing what you're doing. Because I'm trying to write the file format. So the format expects them to be 1 byte. I was under the impression that this was your code, this exporter. Yeah, okay. Okay, so this is your code. So the unsigned int, that's unsigned int, I think by default is that 4 bytes, isn't it? 4 or 8 or something, I don't know. It does though, because it's writing the whole thing. Oh, it's writing you. Oh, it's writing 8-bit. It's writing 1 byte. Okay, I didn't see the U8 there. Okay, it's writing 1 byte. Let me just call it. Let me just paste the values. Can I keep source? No, I don't want source format. I want destination format. There we go. Now let's do that. This is still per texture. This is... Oh, my goodness. Oh, what's going on here? Get rid of that formatting there. So we have a height and width, and the equivalent variable is the... where was it? No, it's not under animation struct. What are we doing? We're doing textures, right? Textures. How are textures loaded? Textures are loaded as something. Is this under tga.h? Get the feeling it's under tga.h. Ah, .c. Oh, it gets written directly. So there's no texture struct that holds this together. It's just whatever the height is. Right. There we go. Oh, I just write it as width and height. So wait, what's the first thing? Height and then width. Height, texture, width. Let me add that in as like a hint as where to look for it. All right. So then after that, this. Go. Wait, do I want that here? There we go. After that, we write per T size, texture size. Oh, per pixel, and we write the pixel dot A. Pixel K dot A. So the T is what was it? Texture, right? No. Yeah, it is a texture. The texture has a component called pixel, and the pixel is a pixel T, and the pixel T is up here. Oh my goodness. Okay. I'm not sure I follow. But, why are we specifically writing A? Yeah, correct. But we are grabbing A, which one would think is the alpha channel, but apparently is some. So we're using. Okay, so that's the palette code index. So this is. Oh boy, this is gonna be a heck of a thing to write. I.A. So this is palette code index stored in alpha channel data. This pixel T came... Well, actually, pixel T is not as it is stored in... Wait, this is all... I'm basing off the converters implementation. And here, add texture to VRAM, it's literally just, let's call it index. And we don't care where it's stored in right now, because it shouldn't be stored there to begin with, and we're not going to use it like that anyway. Palette code index, right. So we're just writing palette code indices. And the size of this is... Well, wait, what's the size of how he's writing it? 1 char. For texture per pixel. Okay, this is not an actual thing that exists, but we'll just roll with it. Everything else is a thing that exists somewhere. Okay, this is the map. I think we're done. I think that's it. So this is enough information to try and take it into Blender, over in Ya, and try to write a plugin in Python that will take into account this data structure and crap something out. If I learned how to write plugins for Blender properly. So, yeah, okay, there we go. This is not exactly what I was planning on doing today. I was planning on making art for people, but basically no one actually was interested in the idea, or at least no one came up and asked for it. However, Ponut did say that this would be a lot more better use of my time, and I decided to do it anyway. So now we got a map, so we know what needs to be done. Until Ponut decides to change his format, which I wholeheartedly support, in which case we can change the map around. Okay, you know, Ponut, just because you helped me out here and held my hand, I'll make you art too. We'll try to throw something together in the model converter and you can use it in your game. So yes, Dr. Spod, there is SGL and SBL. You saw us looking at it earlier. But yes, they do suck. They suck really hard. You can't really do anything out of the box with them because you basically have to rebuild an engine from scratch around them. They're utilities for interacting with the hardware. It's basically just saying, if it wasn't for this, you'd be trying to do stuff in assembly anyway, so just be grateful for what you get. Joe Engine is a fantastic place to start, and it is linked below. And for people on YouTube, it's also linked below. Everything's always linked below. Just look in the comment or the description. There's like a list of like 20 links or something, all of them relevant, usually. But yeah, if you want to actually get started in Saturn Dev, make a 2D game in Joe Engine. Just steal one of the examples and modify it with your own textures and stuff. For 3D stuff, right now, the way to do it is to take XL2's stuff. He has Z-Stream tools and the model converter that we've been looking at, or a version thereof, publicly available on the Joe Engine forums and on the Sega Extreme forums. And what we're trying to accomplish right now is Ponut is rewriting that Z-Stream format for his purposes. And I am going to try and help him with a model converter to try and streamline the pipeline. Because one of my biggest hurdles earlier on was trying to figure out the pipeline of how to get started with a model that I want to put in a game and actually put it in a game. So that was the purpose of today. Like I said, my real-life commitments are kind of getting in the way right now. So for the next 6 months or so, or actually really probably the next 5 months or so, I will be slowing down. So I'll only be doing like one coding stream a month. And then because I'm also a beta tester on the Sadiator project, I'll be doing one, firmware, not like a review, but test a month. So next weekend, probably Saturday night or something, if you guys want to see some Sadiator tests, or if you want to see a game tested for the Sadiator, you can request it, and I'll try to load it up on an SD card and see how well it works. Everything should be working well enough. I think the only problems that Abrasive is working on right now is additional features like disk swapping and stuff, or because I think at least for American releases, I'm pretty sure all the other problems have been addressed. I think this is a good enough stopping point for now. We've been examining a whole bunch of 3D model code for the last 3 hours or so. We have a actually, Ponut, how can people access this model viewer demo? Do you want to put something together, or should I put something together? I don't want to steal your code because I did literally nothing for it. But if you want me to post it up under my GitHub, I can. Or if you want to just if you just want to keep this to yourself for now and just wait. Okay. So what I'll try to do sometime this week is on the YouTube description for this video. But okay, I'll wait for the but. What's the but? Okay, so I'll clean it up a bit. So I'll take away all the extra files so you can just analyze what's still there. It'll have the comments that we added today with it. I'll also include this GVP map, so if you guys on your own somehow beat me to the punch and create your own model exporter or model adapter or what have you, then you can use it. Hopefully you share it and then I can go off of it. But I will post a cleaned up version on a GitHub link below, and I'll try to credit Ponut as best as possible because he's the one that actually wrote it, and with some fundamentals that XL2 originally did. A lot of Saturn dev is basically just stealing someone better than you stuff and then adapting it for your own purposes anyway. So this is still a work in progress. I'm planning on making changes to this format and hopefully helping Ponut adapt to them in a way that is logical, but I'm gonna let Ponut take the lead on here. If he wants to add a feature, then I'll just change whatever I'm doing to be compatible for it. But for now, I think this is a natural stopping point. I'll see you guys next time. Unless someone has a specific request. I think we're gonna try rating someone, so give me a minute, and we'll see who is available for rating. I'm sure someone on the pirate network, the Go Pirate Software Network. I see Slap on. I actually have no idea who Slap is, but I know that he's on. He's got 0 viewers. So he's probably just doing a test stream or something like that. I don't know. Let me see if Go Pirate is on. Huh, that's weird. Okay, let's raid this random channel and just kind of surprise him with a bunch of viewers. He's got no viewers right now. Let's see what happens. So I'll see you guys next time.